Hello, everyone. My name is Zach, and welcome back to my series on the CCNP ENCOR exam. If this is the first video you've watched in this series, this is our first video covering the actual content of the exam as we're learning it. So if you want to know the beginning, the whole story of why I'm making this series, make sure to go back in the playlist or find the playlist on my channel to watch it from the beginning. But if you just want to learn about the exam part, this would be the first video to start with. So today we're going to be talking about design principles of an enterprise network. Now, it's important to keep in mind when we're talking about CCNP is that in the CCNP, we're focusing on large enterprise networks and some medium stuff as well. But really, we're looking at huge networks. This is a professional level certification. We're looking at higher levels of networking. So the concepts that you see in here may not necessarily apply to a smaller organization. And that would be something that a CCNA or even someone who's uncertified might be able to manage because the network is so simple that you really don't need the robustness of these design principles. Now, if you've done CCNA already, I took the CCENT exam and the CCNA routing and switching exam before it was retired. And some of these concepts were already covered for me. So if that's familiar to you, make sure you tune in still because there is some new content at the very end that may not be covered. Definitely, I know it wasn't covered in my exams, but is definitely a new technology that will be covered in this exam and may have been covered in the new CCNA, but I'm not entirely sure. Also, keep in mind that the information that I got from my presentation that I'm about to show you, I got from Cisco. I got it from Google, but Google pointed me to Cisco. Cisco has really great resources. If you need to know about anything that we're talking about here, Cisco does usually have a white paper or a Cisco learning area of their website that has the information. So I'm going to leave the links to my resources in the description below, and they definitely go in far more detail than I do. This is just kind of a brief overview to get you primed and kind of get you the my network engineer perspective on how these things work and how they apply to the exam and what takeaways you might want to take to work if you're going to work as a network engineer or a network administrator. So I'm going to get my slideshow up here. And like I said, today we're talking about design principles in enterprise network. This maps to 1.1 of the exam objectives, which I encourage you to look at and download the PDF if you can. So first, we're going to start with the hierarchical network model. Now, if you're from CCNA, this is probably familiar to you. This stuff was touched in that exam. The hierarchical network model is split into three different layers. You've got your access layer, your distribution layer, and your core layer. The access layer is for user-facing endpoints. This is your PCs, phones, wireless access points, any kind of voice over IP stuff exists on this layer. These are all the end of the road, end devices. Next, you've got your distribution layer, and the distribution layer is aggregating all of this access layer stuff into one point, and this is where a lot of your network services are going to be running. Lastly, your core layer is for high-speed packet switching. This is your network backbone. It is the thing that is going to connect all of your distribution layer stuff that will be going out to your routers and to your WAN links and your internet connection. So let's talk about the access layer first. As you can see, it's highlighted in the very bottom here. Access layer, it's going to phones, PCs. It's at the very bottom, and it's for getting all of your devices connected to the network at the very edge of your network. So typically what you'd see here are layer 2 switches. Typically in most enterprises, these switches are going to be fixed configuration switches. Fixed configuration meaning there is ports in there that are permanently fixed in place. There are no modules. There are no chassis that you pull things in and out of the switch in order to add more capacity or change the type of ports that you have. You may see some GBIC slots where you can plug in fiber connections if you're doing fiber backbone to your distribution layer, but none of that's necessary. this is high availability. All of your end devices are connected to this. So if you lose a switch, they don't have connections. This is where you're going to do a lot of your end device services. Port security. You want to make sure that people can't just plug their computers into the network without authorization and do whatever they want on the network. This is also where quality of service, or QoS, classification and marking, is going to be. We're going to talk about quality of service later on in the video series, so pay attention for that if you're not familiar with it. We'll cover that at a later time. ARP inspection going on here. Once again, covering that later. Virtual access control lists. Very important. Spanning tree is happening here. You have a lot of links at the very bottom. You want to make sure you're not creating loops and creating broadcast storms and taking your network out. And then because access points and voice over IP phones are at this layer, you also need power over Ethernet, or PoE, to power those devices. And your voice VLAN is going to be primarily connected to this. So next you've got the distribution layer. Distribution layer, all of your access layer devices are going here. And it's really where most of your network services are being hosted from. So these are aggregation of LAN and WAN links. So you may, now if you're thinking about access layer, you're talking about having all of your access layer devices connected to it, phones, computers, etc. But you may also have a distribution switch that is an entire server cluster, or your data center, that are all plugged into one distribution layer switch. You also may have a what's called a WAN edge distribution layer, which is all of your WAN links that are going all to your branch offices may go into one distribution layer switch, where that then gets brought into your network. You may have an internet zone, where you may have a demilitarized zone, or DMZ, where servers that are public facing may be sitting. So you're looking at all of your access layer switches are connecting to this, and also you have these different WAN LAN zones that are being covered by distribution layer switches. So here is where you're going to do a lot of policy-based security, access control lists, filtering. You're going to be doing routing services between your LANs and your VLANs. When I started learning Cisco, I always thought the router did all the routing, which makes sense to me. But what I learned is because of the much more heavily utilization of layer 3 switches, you can really reduce the amount of work that your router has to do by allowing your distribution layer switches to do all of the routing for your internal VLANs. So what you're going to be seeing is VLAN interfaces. That's where, and then those are going to be your default gateways for your VLANs for your access layer devices. They're going to go to the distribution switches, and that's where all the distribution is going to be happening. So that what that does is that all of your traffic that doesn't need to go out onto the internet or over the WAN links doesn't even see it. It's a lot more efficient and a lot more good for fast, responsive networks. Oftentimes, you're going to have 2 or more distribution switches per access zone, per distribution zone. You'll have 2, as you saw in the diagram on the previous slide. So you have redundancy and load balancing. You want to utilize all of these because of all the services that are running. This is also your boundary for route aggregation and summarization. You want to plan your VLANs so that your internal VLANs are all kind of in the same area, same block, so that your router at the very top of this area can summarize that route. So you can say all of the networks between 10.0.0.0 to 10.8.0.0, those networks are all here. And then you can subdivide those into different subnets. So summarization. Broadcast domain control. So your routers and multi-layer switches are not forwarding broadcasts all over the place. It's all going to be, you want to keep broadcasts and multicasts in one network layer if you can. You don't want to get it to going to the whole network, because that's going to create a lot of congestion and a lot of inefficiencies in your network. So now we move on to the core layer, and you expect all this complicated stuff that we've been doing at the distribution layer, that you would expect that the core layer would have all kinds of services running, and really that's just not the case. The core layer is high-speed switching, moving things to and from places as quickly as possible. This is also a very important part of your network. This is your network backbone, so you want reliability and fault tolerance. You're going to have more than one of these core switches. And if you want to increase the effectiveness of your core layer, you don't necessarily want to buy a huge switch like 48 ports or 24 ports. You want faster equipment, not more equipment. So you'll have two super powerful, super fast switches, and the goal is to get things in and out as quickly as possible. You don't want to be doing any kinds of packet manipulation here. You're not doing port security or packet inspection, quality of service classification, DHCP, DNS. None of this is happening in the core layer. Your core layer is just in and out, like I said. So if you're not in a huge network, you're in a smaller network, you may not need to have a dedicated core layer and a dedicated distribution layer. If you're in a medium-sized enterprise and you don't have too much going on, maybe you don't have a server cluster, maybe you don't have a whole bunch of WAN links that you need to aggregate with a distribution layer switch, you can use the two-tier model or the collapsed core model, as Cisco calls it. This model, it takes the distribution layer and the core layer and combines into one. You're buying less equipment. It's cheaper. And if you're a smaller enterprise, having a separate core and distribution layer might be a bit overkill. This is not going to be used in a huge enterprise, but it's something you need to be aware of because you may not work for a large enterprise. You might be working for a medium enterprise. I work for a company that has about 3,500 employees, about 1,500 endpoints, and this is the model we use. We have. It's actually not Cisco's recommendation, but we have one 4500X layer 3 switch that handles all of our core and distribution services. It does DHCP, but it's also connected to all our routers, and then it goes to all of our access switches on the floors of our building. So this is the new stuff I was talking about. So this spine leaf architecture is something you're not going to see in your regular old enterprise. This architecture is all about data center. And when I say data center, I'm talking about, companies that are doing a large amount of virtualization between network racks. So you'll see this in large enterprise that may have their own private cloud. But this is the kind of model they're running in places like Amazon Web Services and Microsoft Azure. So when you look at this architecture, you want to think that underneath all these leaf layer switches, which you see at the bottom, there are racks and racks and racks and racks of servers. And then your spine layer is the thing connecting all of them together. So how the spine leaf architecture works, you'll see that there are 4 spine switches in this example. And at each leaf switch, you'll see 4 connections. So every single leaf is connected to every single spine. And the reason for that is if you're on this switch right here, say you've got a server down here, and you need to get resources from this switch over here and this server rack over here. No matter where you are, no matter which rack you're in, there's only one hop in between the resource that you need and where the resource needs to go. So what this creates is an environment of ultra fast, ultra reliable, low latency connections between two devices. Because when it comes to virtualization, a lot of times you may have a server that is processing resources in a storage space that's in another place. And you need it to happen flawlessly because that's what you're trying to deliver fast performance to your customers. So this is, like I said, something you're only going to see in data center environments, but it's really cool stuff. It's a kind of a new way of thinking when it comes to operating a data center. And this is something you might encounter if you're working for a large enterprise. So that's all I have for you guys today. I'd like to thank you guys for watching. I'm going to try to continue to upload these once a week. I am working full-time as a network engineer and going to school full-time and also preparing for exams. So there's a lot of stuff that I have to do, but I really think it's important to be able to share this journey with you guys, and then hopefully you guys can follow me and learn some stuff along the way. This is kind of a new thing I'm trying. So if you like this video, please like it. If you know anyone else who's trying to get their CCNP, or maybe someone who's just maybe interested in taking the CCNP exam, send them my way, share the video with them. And if you want to continue watching this with me, make sure you subscribe and ring the bell. That's, everyone has to do that. That's what all the YouTubers are saying nowadays. So like I said, again, thank you all for watching. And in the next episode, we're going to be continuing along our journey and looking at redundancy protocols like HSRP, SSO, and just redundancy in general. Thank you all for watching, and I hope we all learn more together in the next episode. Thanks.